Hello, dear students. In the previous lecture of p block elements, we have started our oxygen family, in which a physical property we have started. And out of these physical property, we have done atomic radius, general electronic configuration, then comes to ionization enthalpy, then electronegativity, and melting boiling point. For these all you have to do definition, trend, what is the trend in the periodic table of that particular oxygen family, and what is the reason behind that. Okay, one more is a physical properties left we are going to discuss today. That one is electron gain enthalpy. Okay, so at electron gain enthalpy is first thing energy required, or energy, you use the word energy exchange first thing. Energy exchange, because in some cases energy needed, in some cases energy get released. So energy exchange while taking, or you can say gaining electron take place. Gaining electron take place by any atom. That is the electron gain enthalpy of that particular atom. So, but we talk about the oxygen family. So you know very well that oxygen is a non-metal, high electronegativity. So oxygen by, or its group element usually goes in the stability by gaining the electron. So that's why first thing electron gain enthalpy will remain negative. But if you see clearly, the electron gain enthalpy is minus 141 kilojoule per mole for oxygen. Then for sulfur it will become minus 200 kilojoule per mole. Then if you move further to selenium, tellurium, it will becoming less negative. Mean to say, start decreasing to that minus 191, then minus 180 in this trend manner. So here is the anomalous behavior in case of the electron gain enthalpy, that it become more negative from oxygen to sulfur. However, oxygen is more electronegative, but then it becoming less negative. First thing, electron gain enthalpy will becoming start less negative if atomic size is increasing. So while in this case atomic size is increasing, but electron gain enthalpy become more negative, that arise the exceptional question. In every family you will get it. In nitrogen family you go, or halogen family also we will discuss that chlorine have more negative electron gain enthalpy as compared to fluorine. So what's the reason? Because second period particularly, like oxygen element have small size. That is the reason the electron gain enthalpy is more negative of sulfur than the oxygen. Due to small size, there is electron repulsion become. Okay, and that's why we need the stability arises is lesser. Mean to say, lesser energy get released, and that's why oxygen have less negative electron gain enthalpy as compared to sulfur, and after that it becoming less negative. That is the particular trend for electron gain enthalpy here. Okay, so these are the 4 or 5 physical properties regarding the oxygen family. We have completed today the physical property. Now let's move to chemical properties. So you know very well, in chemical properties, 4 are the basic chemical property we always discuss. The first one is oxidation state, and other are reaction with hydrides, or you can say hydrogen, reaction with oxygen, and reaction with halogens. So these 4 properties we usually discussed about the all families. So let's start the chemical properties, starting with the first one, that is oxidation state. So you know that the general electronic configuration is NH2NP4 for this. So this will define you the actual what kind of oxidation state will be shown by this group element. So you know that here 2 electrons are needed. That's why the all element exhibit -2 oxidation state. However, polonium, which is metal, it hardly exists in -2 oxidation state, while the rest of with metals always show -2 oxidation state predominantly. Which, if you talk about only oxygen, oxygen is never showing positive oxidation state. The only case, why? Because oxygen is electronegative, highly electronegative, but fluorine is more electronegative with the oxygen. So that's why if you go for the oxygen positive oxidation state, oxygen 2 compound is known only where it exists in positive oxidation state. Here oxygen is +2, here oxygen in +1 oxidation state. This is not this is unstable compound. So there is only one or two cases where oxygen exists in the plus oxidation state. Otherwise, with any element, oxygen always exists in the -2 oxidation state, particularly. Okay. Now, if we go for the further element like sulfur, selenium, tellurium, so they exhibit +2, +4, +6. These are the predominant oxidation states shown by them. Despite -2, -2 also shown by them, but +2, +4, 6 is more favorable. Which +4 and +4, 6 is more predominant in case of these group elements. They hardly show +2 oxidation state. +4 and +6 are most commonly they are showing. Okay. Now, you know that if you talk about the +6 oxidation state, the stability of +6 means to say higher oxidation state goes on decreasing down the group. Why? Due to inert pair effect. Okay, that's why +6 means to say higher oxidation stability goes on decreasing particularly. And due to this inert pair effect, a lot of changes get possible in the nature of the compounds of particular these elements. Okay, like which will be oxidizing, reducing. Such nature is get determined by this what kind of oxidation state they can occur. Okay, now. So, if you go for the oxidation state, I am summarizing you what you need to tell. Oxygen can exist. You have to tell separately regarding the oxygen first thing. That it can exist only in negative -2. With only positive case is with the fluorine. Then rest of you will talk, they all show the -2, but +2, +4, +6 also is shown by them, and +4, 6 are more predominant. Then you will tell about that yes, +6 oxidation stability goes on decreasing down the group due to inert pair effect. Now, the next thing you need to discuss is anomalous behavior of oxygen. That why oxygen is behaving strange. You see that due to oxygen's atomic size, a lot of properties are not according to they should be. They are becoming exceptional particularly. And why there is always exceptional behavior of the second period element with the respective group element due to their small size. First thing. Second thing, high electronegativity. So second reason is high electronegativity. So anomalous nature of this oxygen is due to small size and due to high electronegativity. And third reason is due to absence of empty d orbital, while that is present in the other group elements. Empty d orbital is present in all elements like sulfur, selenium, tellurium, but in oxygen it is not present. So that's why covalency of oxygen can be only up to 4, because 4 orbitals itself. While if you talk about the lower group elements, they can extend their covalency from beyond the 4, 5, 6, such like that. Okay, so that is the particular region that our oxygen is showing anomalous character. Okay, so this is the first chemical property we had discussed. Now the next one is reaction with hydrogen. So you know all that if you represent oxygen family members with E, so they are forming such kind of hydrides, H2E. Okay, while H2O is extensively involved in the hydrogen bonding, you know that, and there is exception question that why H2O is a liquid, H2S is a gas. Why? Because H2O is involved in the high hydrogen bonding due to high electronegativity of oxygen. But now what we have to discuss in case of the hydrides, that if you talk about the acidic character goes on increasing down the group in case of the hydride. Why? Because if you talk about the bond association of He, this bond association enthalpy is decreasing. So that's why hydrogen release will be more rapidly. So that's why hydrogen get released, and if hydrogen get released, that will prove the acidic nature particularly. So in case of hydrogen, must you have to tell what kind of hydrides they are forming and what is the acidic character trend of the hydrides and what is the reason behind that. So the acidic character trend is increasing down the group due to decrease in bond association, or you can say increase in the bond length particularly. Okay, so today you will homework is to read the chemical property, or you can say read the topic we did. Second, sort out 5 exception based here, exceptional sort type, Q's and unsure in rough notebook. Third, make your notes regularly. Make your notes. Okay. Thank you.